All right, so we know the three primary trig ratios. We call them the primary trig ratios because they're actually something, a set of ratios which we sometimes call the secondary trig ratios. They're also known as the reciprocal trig ratios. Gentleman in the back, you with me? Luca? Yeah? Yeah, I know, but you were staring over there, so just making sure. Okay, so our primary trig ratios, the ones we know and love, there are SOHCAHTOA trig ratios, right? Sine, cosine, and tangent. And we have what are called secondary or reciprocal trig ratios, and their names are cosecant, secant, and cotangent, and they are essentially just the reciprocal of the three primary trig ratios. So cosecant has an abbreviation just like sine has an abbreviation and cosine and tangent, and the abbreviation for cosecant is CSC. And it is basically just equal to the reciprocal of sine, and what that means is that cosecant is actually going to be equal to hypotenuse over the opposite side of our triangle. Okay, so it's important to remember that when I say 1 over something, I just mean reciprocal. So when we say like 1 over sine theta, we're saying like the reciprocal of sine theta. Okay, this is actually very different than sine inverse, right? So this guy, you don't have to write this, but this is not equal to, it's not the same as like our sine inverse that we use when we're isolating for angles, okay? This simply just means the reciprocal. The inverse is like the opposite of the function, whereas the reciprocal is just like the flip of the function. It's just the function, but upside down. Okay, so cosecant and sine are reciprocals of one another. Secant, abbreviated SEC, is equal to the reciprocal of cosine, and that means that is equal to hypotenuse over adjacent. And then our last one, cotangent. This one's nice and easy to remember because it actually has the word tangent in it. It's abbreviated COT, and it's the reciprocal of tan, which means that it is adjacent over opposite. Okay, so for our purposes in this course, we really just need to know, like, okay, which one is sine's inverse, which one is sine's reciprocal, which one's cosine's, and which one's tangent. If you decide to take advanced functions in grade 12, you'll learn about how to graph these functions and what they actually look like. But for our purposes now, we just want to know that they're the reciprocal of sine, cos, and tan. A little thing that I kind of like to make a mental note of is a lot of people get confused because sine, we have sine, which starts with an S, and then we have secant, but these actually don't match up, right? So sine's inverse is actually cosecant, and cosine starts with a C, but its inverse is secant. So just remember that they're opposite of what you think. Just because sine starts with an S doesn't mean that its reciprocal is secant. It would be nice if it was called that, but it's not. So just remember that they're opposites. Sine matches up with cosecant, and cos matches up with secant. And then, of course, we can remember cotangent because it has the word tangent in it. Okay, so if we know these things, we should be able to actually set up a nice little chart for what all of these guys are from the special triangles. I'm going to start with this set right here first because those are directly from the special triangles. So if we set these up, I'll just draw the special triangles up top here just so we can remember where we're getting these values from. Okay, so we're going to start with 30 as our reference angle here. And if 30 is our reference angle, we'll just label our sides based on that. So we'd have adjacent, hypotenuse, and opposite here. And then I should be able to set up all 6 of these for sine, cosecant, cosine, secant, tangent, and cotangent. So sine of 30 is opposite over hypotenuse, which gives us 1 over 2. And because cosecant is the reciprocal of that, that means that cosecant is actually equal to 2 over 1, which just equals 2. Okay, and then for the second one, cosine of 30 is adjacent over hypotenuse, which means that secant is just going to be the flip of that, 2 over root 3. And then for tangent, opposite over adjacent is 1 over root 3. Opposite over adjacent. Or, yeah, and then cotangent will be the flip of that, which actually just reduces to root 3. Okay, and that's because cotangent is the reciprocal of tan. Okay, now we can do it with 45. So if I use, doesn't matter which 45 we choose, but we'll just label based on that top one, adjacent, opposite, and hypotenuse. We know that sine is equal to 1 over root 2, which means that its reciprocal is going to be equal to root 2 over 1, which is just root 2. Okay? If you want to state it with its denominator rationalized, that's fine too. It's equal to 1 over root 2 or root 2 over 2. Same thing. Cosine is actually the same because this is an isosceles triangle. So secant ends up being root 2 over 1, which reduces to root 2. And then tangent is actually equal to 1 over 1, which reduces to 1. What's the reciprocal of 1? 1. So cotangent of 45 is also equal to 1. Paige? Well, we should already know most of these, right? So the only thing that I'm showing you here is that we're flipping them for the other ones. We have all of the sine, cosine, and tangent information in our first lesson.
But I mean for like everything now.
Okay, I'll give you guys a second to catch up.
Wait, so what do these arrows mean?
I'm just showing that these are reciprocals, like sine and cosecant are reciprocals. So when I go from 1 over 2, the reciprocal of that is just going to be 2 over 1, right? So I'm just showing that those things are kind of like pairs. Alex? Yeah, we're just flipping them, yep. Okay, the next one we're going to do is 60. So I'm going to label the sides of my triangle adjacent, opposite, and hypotenuse based on that 60. And then I'm using SOHCAHTOA to set these up. And then all I need to do for the reciprocal ratios is just flip. So for cosecant, I will flip the value that I get for sine. So this should be pretty quick, like if we kind of understand SOHCAHTOA and we know how to use our special triangles. If I'm looking for sine of 60 degrees, I'm doing opposite over hypotenuse, which is root 3 over 2 in our triangle above. Okay, and then for cosecant, we just flip. So I'll get 2 over root 3. This can also be written as 2 root 3 over 3. Andrew, can you put your phone away, please? Okay, and then for the next one, can somebody tell me what the cosine of 60 would be equal to? Elise? 1 over 2, perfect. Adjacent over hypotenuse. And that means that secant, when I flip 1 over 2, I get 2 over 1. So that reduces to 2. Okay, and then for the last one, can somebody tell me what tan of 60 would be equal to?
3 over 1.
Okay, very good. Yep. And then when I flip that, I get 1 over root 3. Okay, for 0 and 90, for now, I'm going to explain this a little bit more in depth in some future lessons. Actually, do I have it in a future lesson? I'll explain it now. Okay, for 0 and 90, we don't have to use our calculator. But we are going to use something called the unit circle. And the unit circle is just a circle with radius 1. Okay, it's kind of like 1 is a nice number because it's like it represents like 1 unit, and then we can scale up and scale down from there. So we like to kind of express this as maybe like the smallest version of a circle with like only 1 unit of length as far as like radius goes. We also have to remember what we talked about in one of our previous lessons, which is what are we actually doing when we do trig? And we talked about how we have a point xy on the outside of a circle, and we can set up the trig ratios with a right angle triangle, this being x, y, and the radius of the circle. Okay, so we talked about this in a previous lesson, and we had set up the trig ratios in terms of like x, y, and r. So just to remind you, we set up that sine of theta was equal to opposite over hypotenuse, or y over r. And we set up that cos theta was equal to x over r. And tan theta was equal to opposite over adjacent, which is y over x. We can also set up the trig ratios in terms of x, y, and r, or the secondary trig ratios. And that would mean that cosecant is equal to r over y. Secant is equal to r over x, and cotangent of our angle is equal to x over y. Okay, so here's the idea. I have a unit circle here, along with my angle measurements that we've been kind of using for the past few days. Not the greatest circle. Try one more time. There we go. Okay, this is going to be my unit circle, which means radius equals 1 here. So if I have a point at 0 degrees, can somebody tell me what that xy coordinate is if this radius of the circle is equal to 1? Like, what would this be on a Cartesian plane? How far am I going over on the x-axis? 1. And have I gone up or down at all on the y-axis? So this is the point 1, 0. Agreed? Well, it doesn't matter how big or small I make it, right? But this is 1 unit here. Okay, so my x here is 1, and my y at this point is 0. My radius is 1. So if I'm trying to find the sine of 0, I am doing y over r. Well, at the point where rotation is 0, what is y? What did we say at this point right here? 0, and radius is 1. And so we get, for the sine of 0, we get that it's actually equal to 0. Now, if I try to do the cosecant of 0, I'm doing r over y, which actually gives me 1 over 0. What do we know about the value 1 over 0? That is, yeah, not possible. So it's actually undefined. So we'll just put u for undefined. Okay, cos of 0. That's x over r. What is x at this point? 1. And radius is 1. So cos of 0 is equal to 1. Okay, and then I think we can do secant ourselves. If we're doing the reciprocal of 1, then if cos is equal to 1, secant must also be equal to 1. Okay, and then the last one, tangent of 0. That's equal to y over x. What is y and x at this point again? Well, I'm looking back down at this point here. It's 0 over 1, so it's actually equal to 0. And we can imagine when we do the reciprocal of 0 over 1, we get 1 over 0, which is also undefined.
It's used for cos.
Yep, It's just 1. 1, the reciprocal of 1 is 1. Alex?
What? Well, I understood till like the first point and then the unit circle, so the radius is 1, right? So we write
Yep.
into the...
And I'm using this point over here,
Okay.
and I'm using these guys. So if I know that sine is y over r, y at this point is 0, and the radius of the circle is 1. So I'm doing 0 over 1, and that's equal to 0. Right? So I'm just plugging in the x, y, and r for the respective trig ratios as we're filling this in.
Radius is always 1? No matter what?
For these guys, yes.
So 0 and 9 is going to do this equation no matter what. So
Pardon?
The Raskin test for 0 and 9 is B, right?
Yes.
Okay.
Although the point changes once we rotate up to 90. Okay? So for the 90-degree one, we're going to use the point up here on the unit circle. And I think I heard it back there. Was that you, Daniel? Luca? What is it? 0 and 1. Okay, so my x here is 0, and my y is 1. It's 1 unit up on the y-axis. So again, when I set up my sine of 90, I'm doing y over r. And y at this location is 1, and the radius is 1. So I actually get 1 for the sine of 90. Okay, and we know the reciprocal of 1 is 1, so I can fill that in for cosecant. Karen?
I'm confused why it's 0 and 1.
So if I look at just a regular Cartesian plane, and I go over 1 unit or up 1 unit, what is this point on the y-axis?
Yeah, but it says you're finding 90 though, right?
Yes, so that's the rotation, 90 degrees up here, right? That's the location of 90, but I'm still going 1 unit up on the y-axis.
Wait, what information are you using? Like, what is this based on?
I'm using this information right here,
Sorry, where?
right here.
I know, but where'd you get that from?
So if this is on a unit circle, which is unit, it has a radius of 1, I know that any point on the very, very outsides of this, like on those 4 quadrants, 0, 90, 180, and 270, must be 1 unit in length, because this is actually the radius of the circle right here. Right? Do you agree that that's equal to the radius of the circle?
Why would that be the radius when like this could be the, why isn't it more than
This is also the radius of the circle. Right? So that's where I get the point 1, 0. It's because I'm going 1 unit over on the x-axis, which is the point 1, 0. But then when I go 1 unit up on the y-axis, that's the point 0, 1. It's on the y-axis. So I haven't gone to the left or to the right, but I have gone up. Karen?
So is the radius 1?
The radius is 1, yes.
And the y is 1?
And the y is 1, yeah.
X is 0?
The x is 0. Okay, so can somebody tell me what the cos of 90 is equal to? Yeah, it would be 0 over 1, which is 0. Which means that its reciprocal is undefined. Very good. And then last one is y over x. So in this case, that's 1 over 0. So what does that give us? It's undefined. So you guys can imagine if we try to do cotangent of 90 now, that's x over y, which is 0 over 1. So that actually gives us 0 for cotangent. Okay? You can enter into your calculator sine of 0, cos of 0, tan of 0, and get these values. I just want you guys to know where they're coming from. You can also do this as well with 180 degrees and 270 degrees as well. You would be using, can somebody tell me what points I would be using? Like what would this point be over at 180? Yep, and what about this one down at 270? Okay, so we could set up all of those guys with x, y, and r using that unit circle.
When do we use
Okay.
this, like, what's it called, like CSC, like when do we use all that?
We're going to use them just like in a variety of questions to, I'll show you some examples for when we'll like apply them.
Like what would the question ask?
You'll see some examples. Okay, do we need to take a little brain break here?
I need to ask about the homework stuff.
Okay, so this question right here asks us to determine all 6 trig ratios values And it tells us exact value, meaning no decimals at all, for angle A. So angle A is our reference angle. This should be pretty quick to set up because we already know all sides. There is no need for us to find the measure of angle A in this. All I'm doing is I'm setting up the side ratios using opposite, adjacent, and hypotenuse. So if I'm doing all 6, we can start with the primary ones, sine, cosine, and tangent, and then we will do the reciprocal ones. So we know that sine is opposite over hypotenuse. So in this case, we'll leave it as 12 over 13. And then cosine is adjacent over hypotenuse, so 5 over 13. And tangent is opposite over adjacent. So here we have 12 over 5. Okay, those are all of our primary trig ratios. Then we're going to set up the secondary trig ratios here.
When would you use the secondary trig ratios? Like, why wouldn't you just use the primary ones?
Yeah, so the secondary ones, we're just being introduced to them because we use them sometimes like for other things. Like there's things called like trig identities, which we'll learn at the end of this unit. So it's just important for us to know like their relationship to the primary ones. But yeah, for the most part, we use the primary trig ratios. Okay, so I know cosecant is just the flipped version of sine. So I'm just going to take my sine value and I'll do the reciprocal. Guys at the back. Secant is going to be the flip of cosine, which is 13 over 5. And then cotangent will be the reciprocal of tangent, so 5 over 12. Okay, guys, what's the problem here? Any questions for this one? Alex?
So once it's all 6 trig ratios, we use the regular ones and the flipped ones.
Right.
When it's 3, we just use those 2, right?
Yeah, so if you see just primary, then we're looking for sine, cos, tan.
Those first 3, right?
Yep.
All right, got it.
Carla?
So when you're flipping the ratios, what's
Yep.
the exact reason for trying to flip them? Like, is there a purpose?
Mostly we're just learning about the relationship between like sine and its reciprocal. So just kind of like grounding that knowledge for now, and then we'll use them for some other things later.
Okay.
Okay. So we are going to find possible angles, and I'm actually just going to add theta is going to be between 0 degrees and 360 degrees. So be mindful that if you're tasked with finding theta, and theta is between 0 and 360, you have to find all possible values of angle theta. Okay? So we learned about this in our last lesson. If I'm approached with a secondary trig ratio, the very first thing I do is I change this to its primary ratio, and then I solve as usual. So cosecant, when cosecant is equal to 8, we want to think about it as if it's 8 over 1, right? We know any number has an imaginary denominator of 1. So when I change this to its primary ratio, it's actually going to be that sine is actually equal to 1 over 8. Okay, now there's 2 areas in my quadrant grids that I could have a positive sine value, right? Positive 1 over 8. And I'm going to use the cast rule to decide on that. Okay, so this is kind of a review of what we did at the end of last week. Where could my possible angles be? Elise?
In quadrant 1 or 2.
Yep, in quadrant 1 or quadrant 2, in the all quadrant and in the sine quadrant. So let's just call this one like our theta 1. And this one can be called our second option for theta, or theta 2. Okay, so how do I get sine and theta apart? How do I separate them so that I can just get theta? What was that, Ivana?
Inverse? Negative.
Inverse. Sine inverse of 1 over 8. Okay, so we need some calculators out and in degree mode. Okay, let's round to the nearest whole angle.
7.
Okay, agreed? 7 degrees? Okay, so if this is 7, the reference angle for theta 2 is also 7. So I gave you guys a little kind of like cheat on your last lesson for how we can find theta 2 when it's in quadrant 2. But basically I want this version of the rotation, right? I want the rotation from 0 to my terminal arm here. So does anyone remember how we can quickly calculate that? Yep, that's good, Daniel. 180 minus 7. So our theta 2, because we want like this full rotation minus the 7 degrees to give us that dark black area. So we're going to get 173.
How is that 7 degrees at an angle right there? That does not make sense.
Well, I don't know what they are when I place them in there, so I'm just like putting them in the quadrants they're supposed to be. I'm not drawing it to scale because I'm solving for the angle. I don't know what it is. Okay, guys in the back, I'm like this close to separating you all, so you need to stop. Okay, so for secant, again, the very first thing that I'm going to do is I'm going to flip it to its reciprocal ratio. And that means I flip the ratio. Okay, so the biggest mistake that I see people do when they start to flip these things is they do this. They go, okay, 1 over cos theta equals 5 over 2, and then they get all confused. Like, all you need to do is just switch it to the primary ratio and actually flip the fraction itself. Don't flip this to 1 over cos theta and all that kind of stuff. We're just going to change it to cos theta and actually flip the numbers themselves. Okay, cosine is a positive value. So I'm going to find two angles where cosine is positive. One will fall in the all quadrant because all trig ratios are positive there. Where is the other one going to fall?
In the T. In the C.
In the cosine quadrant. Okay, so we'll call this theta 1 and theta 2. We're going to use cos inverse to get our angle by itself. So cos inverse of 2 over 5.
Wait, why is it this way?
So we have cosine is equal to a positive value. So cosine is positive in the all quadrant, and it's positive in its own quadrant.
Miss Michaelis, it goes 1, 2, 3, 4, right?
Yeah, so it's labeled 1, 2, 3, 4. Okay, cos inverse of 2 over 5? 66 degrees. Do you guys agree? Do you all get that? Okay, so that's this angle measurement right in here. It's also the reference angle over here. So how do I figure out what theta 2 is? Yeah, it'll be 360 minus 66. Yeah, it gives us 294. Okay, so this is basically what we did on Friday, except we just have to do that first extra step of flipping to the primary ratio. Okay, I want you guys to try out part C. I'm going to give you a little head start with that one, and then I'll start putting up my solution in a couple seconds. So see what you can do with that one. So the first thing, guys, let's just pull it back in. We're almost done for today. The first thing that you should have done here was we want to switch cotangent into its primary ratio, which is tangent. So tan of theta should be equal to 16 over 5. I know that my answers, my possible answers, are in the all and tan quadrant because this value right here, 16 over 5, is a positive value. So if I'm taking, guys in the back, if I'm taking the sine or the tan of an angle and I'm getting out a positive value, I must have taken the tan of an angle between 0 and 90 or between 180 and 270. Okay? So what did you guys get as your first theta in that all quadrant there? 73. And then how do we calculate our angle in the third quadrant? Okay, great. Sorry, I don't know how that just happened. Well, like if we think about this logically, here's the rotation that I really want. I want from 0 to 180, and then I go past it 73 degrees. So I want this little slice right here, the 180, and then I want an additional 73 degrees. So we're going to do 180 plus 73. And we should get 253 for that.
I just never know what quadrant to put it in. I don't know how.
So you need to look at whether your answer is positive or negative and which trig ratio we're looking at. So, okay, sorry, I'm just going to wait because I have a lot of people just having their own conversations right now. So we want to place our angles. The first thing that I'm always looking at is which trig ratio are we using? This one we're using tan, and we're getting a positive answer. That means that my angle, in order for the tan of an angle to give me out a positive answer, my angle could have been in the all quadrant, where all angles, no matter which trig ratio I choose, will give me out positive answers. Or if tan gives me a positive, I could have taken the tan of an angle between 180 and 270. So those are my two possible answers because this value, 16/5, is positive. And I'm taking the tan of an angle.
Do we have to do 16 divided by 5 to see if that's positive or not?
You should know that because there's no negative in front of it, that's a positive value, right? If you saw negative 16/5, then I would be placing it in the sine quadrant and the cosine quadrant for this one. Because that's where tan will give me negative answers.
For that one I understand, but how do you know how to put it in like the one that goes in?
Okay, so this one is cosine, right? So cosine is equal to positive 2/5. So I know cosine, again, is positive in the all quadrant because all trig ratios are positive there. And it's also positive in its own quadrant. So I must be taking the cosine of something either between 0 and 90 or between 270 and 360 because cosine's positive there. Because it's cosine and I'm getting a positive answer. The question tells me that it's positive. And we know from the cast rule, so the C represents that cosine is positive in that quadrant.
So do we always have to go back to the cast sign?
Always, yep. We're always looking back to the cast rule. Okay? Alex.
Okay, so like what the grammar is saying, like I wouldn't understand it that well, but like, say if cosine, how do you know exactly what it is, like, between all different ones? Let's say it's the bottom of cosine, right?
So again, we need to fundamentally understand what the cast rule is telling us here. Okay, so can somebody explain to me what is the cast rule? How does the cast rule work? Let's just debrief this one more time here so we're all on the same page. Elise.
So the C represents like when cos would be positive, and then the A represents when like sine, cos, and tan would be positive. Then sine represents when, or the S represents when sine would be positive, and then the T represents when tan would be positive.
Okay, so the all quadrant means that if I take the sine, cos, or tan of anything, any angle at all between 0 and 90, and I take sine or cos or tan of that angle, I'm getting positive answers. In this quadrant between 90 and 180, the next quadrant over, if I take the sine of an answer between 90 and 180, I'm getting a positive value, but for cosine and tan, I'm getting negative value. So you can try it with a value between 90 and 180 on your calculator if you want. Here in the tan quadrant, tan will be positive, but the other two trig ratios will be negative. Cos will be negative, and sine will be negative. And then in the C quadrant, cosine, this is the cosine quadrant, so cosine will be positive, but the other two trig ratios, tan and sine, will be negative. Okay? So let's think about an example here. If I know that cosine of theta equals -1/4, -1/4, I have two potential areas where cosine could be negative. Let's look at the cast rule here. Where are the potential areas where cosine is negative? Okay, perfect. So I would be placing my angles in the S and the T quadrant, and then I would solve from there, right? So I just need to decide, based on this cast rule, where my possible angles are. Based on which trig ratio I'm taking the angle of, or like cos of theta, sine of theta, tan of theta, and then if it's negative or positive. Okay? That's how we place our angles. Okay? We're going to try one more. So determine two angles between 0 and 360 that have a cosecant of -2. So same kind of idea, just slightly different terminology here. So this is what it's telling me. Cosecant of theta equals -2. Okay, so here's our opportunity. So the very first thing that we want to do here is just switch it into its primary ratio. And the primary ratio for cosecant is sine. So think of this as -2/1. So the reciprocal will be -1/2. Okay, so think about it for a second. Don't say it out loud. Using the cast rule, I want to think about where my possible answers would be if I'm taking the sine of an angle and I get out a negative from that. So where, using the cast rule, where would sine be negative? That's the question. Don't say it yet. Just, I want everybody to think about it and see if you can place your angle properly, where sine would be negative.
Or sine would be negative?
Yes.
C and T.
Okay. C and T is correct. Okay. Sine is positive in the all quadrant and its own quadrant, which means it's negative in the tan quadrant and the cosine quadrant. So those are where my first two angles, well, my only two angles should be between 0 and 360. Okay, now our job is to just solve for these, okay? So again, I want to do the sine inverse of -1/2 to get sine and theta separated. And what do we get here? What did you get, Ivana? Exactly?
Yeah, is it exactly?
Yeah, I think it is. Okay, -30. Is that between 0 and +360? Okay, so how do I turn a negative into a positive angle? Luca?
Instead of going this way, don't you go this way?
Yeah, so that means that my rotation was clockwise rather than counterclockwise. I should also be able to switch this into a positive angle, Elise.
360 minus 30.
Yeah, so if I do, I can really quickly change any negative angle into a positive angle by doing 360 minus 30. So I'm going to do 360 minus 30 degrees, and I will get 330. That's actually what I've labeled here as my theta 2, so we can call this theta 2. So theta 2 equals 330.
What's theta 1?
We're going to figure out theta 1 right now. So the reference angle here, guys, this little rotation from my terminal arm in between the 360 line is actually 30 degrees. So whenever I get a negative angle like that, if it's already between 0 and 90, that's kind of like the positive version of that is like my reference angle. So I know that there's 30 degrees between there, and the reference angle will also be the same over in this quadrant, in the T quadrant here. So can somebody think about how we might be able to calculate theta 1 if I want this full rotation from 0 to our arm here?
180 plus 30.
Yep, so I want this. This is 0 to 180 right here. And then I want this extra little slice of 30. So it should be 180 plus 30. And that gives us 210. Okay, now I can do a quick little check if I want to. We talked about how we can do this check on Friday. Does anyone remember? Yep, if you type into your calculator the sine of 210, you should get -1/2. And if I type in the sine of 330, you should get -1/2. So you can check that in your calculator just to make sure you got the right answer. If I get +1/2, I've put my angle in the wrong quadrant because I'm looking for where the sine of theta is actually equal to -1/2. So I want to make sure that I actually get the correct value and also the correct sign. So I should get -0.5 and -0.5, and then I know that my answer is correct.
Do you always get 0.5, or is it just for this one?
This is what we solved for because we were solving for where sine is equal to -0.5 or -1/2. Okay? So you should get back the ratio that you started with and the sign if you've done it correctly. Okay.